Okay, so today I want to go over shorthand electron configurations. And before we do this, I want to go over a few terms that we will be using shorthand configurations and also when we go over ions. So isoelectronic is a term that just means that you have an atom and you have an ion typically. And remember, ions are formed when you lose or gain electrons. And these atoms and ions have the same electron configuration. So these are atoms and ions with the same electron configuration. Core electrons are electrons in the lower energy levels. So I will show you a configuration so you will see what the core electrons are in that configuration. The valence electrons are electrons in the outer energy levels. And again, I'll show you that within a configuration. So here we have silicon. So we have the configuration. Silicon has these, configuration of 1s2, 2s2, 2p6, 3s2, 3p2. So if we look at this, we notice here is that the third energy level is the highest energy level number. We then call these electrons, these 3s and 3p electrons, are valence electrons. We would say silicon has 4 valence electrons. The rest of the electrons are what we call core electrons. So silicon has 10 core electrons. We look at germanium. Germanium ends in 4s2, 3d10, 4p2. Only the fourth energy level, the 4s2 and 4p2, are called the valence electrons, so it also has 4 valence electrons. All the remaining electrons, all the way up from 3p6 to 3d10, these are all the core electrons. So germanium has 28 core electrons. So a shorthand configuration is a way to abbreviate long electron configurations. We are typically only concerned about those valence electrons, the outermost electrons. So we skip to the places where we know that we have completely filled electron configurations. The core electrons are completely filled. Those are noble gases. And then we finish the configuration. So first thing we do is these are just the steps, and we're going to work through so you guys can see how these steps are used. The first thing we do is we write the nearest smaller noble gas and put that in brackets. We then find the next energy level after this noble gas, and we resume the configuration until it's finished. So you will see how this works. So here we have chlorine. Chlorine has a configuration of 1s2, 2s2, 2p6, 3s2, 3p5. If you were to write out the configuration for neon, you would see that it's 1s2, 2s2, 2p6. So we replace that part of the configuration with neon in brackets, and then we just write what is left after that, which is 3s2, 3p5. So now I want to put your periodic table to show you this. So here's your periodic table. If we look at, and I'm going to do potassium, potassium's configuration, if you remember from last time, has 19 electrons, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. If you look at this portion here, this is the same thing as argon. Argon is 1s2, 2s2, 2p6, 3s2, 3p6. So we replace that portion with argon. And what's left is just 4s1. So that would be the shorthand configuration for potassium. Now I want to show you how to do this without writing out the whole configuration first. And so before we do that, I want you to label group 18 as, and I'm going to erase this so we have room. Group 18 is the noble gases. So we're only going to be using those to shorten our configurations. So what I am going to pull up now is the worksheet that is on Google Classroom. We're going to work through a few of these. So you might want to print that out or get that up from Google Classroom. So let's look at that sheet. So let's look at iron. So here we have iron. Let's go to our periodic table. Iron is down here. So what you do is you go to the previous row in the periodic table, which is row 3. You look at the noble gas on the previous row. So the next smaller noble gas, that's going to be argon. So we're going to start out by writing argon in brackets. Then we look at the row number for iron. Iron is on row 4. So we're going to write the 4th energy level, 4. And then we always start with S. Now, if we look at iron, iron has 26 minus 18. This has 8 more electrons than argon. So we're going to start with 4s2. We still have 6 more electrons. So let's look at our diagonal rule. After 4s comes 3d. So what we do after this is going to be 3d, and it's going to be 6. 2 plus 6 adds up to 8. It has 8 more electrons than argon. If we had an exception, we'd have to keep that in mind. So let's do another one. Let's look at arsenic. Here's arsenic. Arsenic is in row 4. It's also going to be using argon. Arsenic has, let's look at our periodic table. Arsenic has 33 minus 18, so it has 15 more electrons than argon. So let's look at our thing. We're going to have 4s2, 3d10. This adds up to 12. We still have 3 more electrons. We look at our diagonal rule. What comes after 3d is 4p. We have 3 more electrons. So that's going to be 4p3. Now the last one I want to do is an exception. So let's look at gold. Gold is on row 6. The previous noble gas for gold will be xenon. So let's write down, scroll down a little bit, this will be xenon. Now let's look at how many more electrons we have. We have 79 minus 54. So let's do 79 minus 54. That's going to be 5. And then 25 says 25 more electrons than xenon. So let's look at this. So actually gold is going to be starting with 6s. So we're going to start with 6s, 2. So now we have to think about, okay, using our diagonal rule, if we go to 6s, the thing that comes after 6s is 4f. So we have 4f, 14. So we've used 16. We still have to keep going. The next one is going to be, so we're supposed to get up to 25. So we have 9 more to go. Then what would come after that, using our diagonal rule, after 4f is 5d. We have 9 and 5d, so it's be 5d9. Remember, this is a column where we have an exception. So we're going to actually change this to 6s1 and change this to 5d10. You notice we did not take anything out of the f. We just do it between the s and the d. And that's our shorthand configuration. So shorthand configurations, you still think about your exceptions. You still follow the diagonal rule. You always use the noble gases to shorten your configurations. So let's just label this. This will be the noble gas from previous row. This is our row number. And we always start with S. Okay, so good luck. Try some of these on the Google Classroom worksheet and email me if you have any questions.